Hi, I'm back to talk more on the hypothesis testing and decision making. This is actually going to be, this is part 3. So if you haven't seen the parts 1 and 2, you might want to watch those first, because that'll add a lot of background. So let's just dive right back into where we were. We were talking about a neighbor, and they were trying to invest and see if this pretzel business was going to be good. They did their sample of 40, and they did not reject the null hypothesis. Again, the null hypothesis was 40% or less of the population would, actually 40% would buy pretzels. So 0.4. Actually 0.4 or more. We went through all this in the first 2 videos, just quickly recapping so you can refresh yourself. That's the null hypothesis. We rejected at a level of less than 0.3. We did a sample and we got 35%. So we accepted. Accept. Now, what we did in the last video, we started to look at all the possibilities of what this population proportion would be, because that's the key. If we don't know what this population proportion is. There's 100,000 people out there. So we did some conditional, what I call conditional possibilities. We looked at H1, where H1 was started with 0.32, because we did a the neighbors did a profit and loss model, and they found that's kind of like the break point. Anything below that is bad. And in our video, in our last video, we found that the probability of accepting the null hypothesis, saying that this is okay, is 0.61. We did that in the last video. We also wanted to examine some more possibilities. We wanted to do a 0.3. We wanted to do a 0.28, which I believe we did 0.28 in the last video, and we've got a 39% chance. And we want to do a 0.2. Now, we did these in the last video. We could redo these, but we already know how to do those. So I'll just put those numbers up. 0.5 is intuitive. If you draw a normal distribution around 0.3, which the probability is greater than 0.3, well, that's 0.5. That's our beta. Now here, 0.2, we would do it for 0.2. You expect that to be small. Expect that to be small, and it is. It's 0.06. Okay. Now let's take a look at some consequences for each of these. And again, these are just 4 of them. There's infinitely many. That's continuous here. There's 0.32, there's 0.3111, there's a whole bunch of them. And we don't know the probability of each one of these. These are just conditionals. And again, these probabilities are betas for each conditional. So we got 4. Now the consequence would be, at 0.32, we just said that they did a profit and loss model, and it's not too bad. So let's say the profit would be, say it's 0. And at 0.3, they did a profit and loss study, and they came back and they said, we're going to lose $2,000, $2K. And then they did one at 0.28 and said, they said, we're going to lose $5,000, 5K. And if we happen to if the population is 20% only taking pretzels, then we're going to lose $25,000 annually. And again, this is a simple illustration. So now for each case, we have a likelihood and a consequence of the bad event happening. And this is what we were starting to talk about in the last video. This is risk. Risk. What is risk? Well, it's a chance of something bad happening We'll call it likelihood. We'll call it L. We'll call the beta L. Likelihood and consequence. Consequence means if the bad thing happens, then what actually occurs here. And you can see it depends. If we were in a case where it was 20% of the population, then we're going to lose $25,000 a year. Not good. So we've got likelihood and consequence. And when you look at risk, you have to look at these two together. Typically, I mean, there's a lot of ways to do this, but typically, you can look at likelihood here and consequence here. And again, a lot of this is decision maker preferences. So, in this case, the decision maker, let's put a value on these numbers. And let's go 1 through 5. 1 being good, and 5 being bad for consequence. 5 being bad. 5. That's a 5. That's a 1. That's a 5. Okay, so maybe he's thinking, or she, or it's the whole group, it's the neighbors, it's a bunch of them. They might say, this is bad, this is pretty bad, this is 5. This isn't too bad, this might be a 3, this might be a 2, and let's just call that a 1. And we'll just give it a slight loss just to make it like maybe, like maybe a couple dollars, maybe $10, just to give this some meaning. So now when we look at that, we can plot our each scenario here, each condition. So this one is a likelihood of 0.61. So this is 1 here, and this is 0 here. So we've got a 1 and a 0.61. That's right. Say that right here. And then we've got a 0.5, which is right about here. So it's 2.5. So it's 2 and then a 0.5 right about here. And then here we got 3 and roughly a 0.4. So that's 1, 2, 3, 4, 5. So again, I'm just roughly drawing. So 3 and 0.4. So roughly right around here. And again, very low consequence, or sorry, likelihood here. And a very bad consequence. So it's way out here, but way down here. Okay? So, and again, it's all how the decision maker feels about this, but this is what we can call a risk rating picture. Obviously, if it's a high likelihood and a high consequence, these things up here are going to be bad. So let's put those in red. So red, that's a bad consequence. Or high risk. Call it high, not bad consequence, it's a consequence in likelihood. So high risk. And likewise, low likelihood, low consequence is low risk. So that's low risk. So the ones we just put up just for illustration, and again, the decision maker is going to deliberate on these pretty heavily and think about them a little bit more. Put their preferences into it, the preferences of the decision maker. So I'm going to put these in kind of blue. These were called, just say they're all medium, say for some reason. They all come out medium risk. Medium risk. So now the decision maker's looking at this and saying, okay, I've got a medium risk. Now, when you make a decision, it's always like a risk-reward. There's a trade-off. You take risk and you get rewards. So risk, reward. We'll put reward in green. That's good. Reward. Well, we know what the risk is. And again, we looked at all the different, we don't know the probability of getting these different conditions, but they all seem to be medium, let's say. So they're medium. Now the rewards are going to be if it's a 0.4, it's a 0.5, all the way up to if it's a 0.9. But we don't know the probabilities of each one of these occurring. So what we will do is assign a reward to the 0.4. Let's say we make $10,000. Say if it's 0.5, we make $20,000. And so forth. If it's 0.9, we're making $200,000. But we don't know that. So we're just going to assume this is our reward structure, and we'll have to allow the decision maker to see this and this. And let's suppose they decide it's too much risk. So that leads me to my next concept here of hypothesis testing. And this is where it's very, very important to not make this mistake. It's more of a practical significance. So let's suppose they decide to go back, and I want to erase this all now. Go back, and instead of doing 40 samples, they're going to up that. They're going to add more to their sample. They're going to sample 400. They want to be sure. They want to eliminate any potential risk. So they're going to go back and sample 400 people. A lot more money involved, but they want to be sure. They think they've got something here. So they go back and they sample 400. And out of the 400, 136 said they buy them. Out of 400, and that's equal to 34%. Okay, in the sake of time, I'm going to illustrate this very quickly, just so with the main points. Now, the null hypothesis, let's look at the null hypothesis. It's still going to be 0.4, but now we got 400, so we know that's going to be a lot tighter. When we look for our 1%, 10% rejection region now, well, we can do that, and we need that x. So we need to get x minus 0.4 over 0.4 times 1 minus 0.4 over 400. Now that comes out to be equal to, and then again we know what that region is from last video. It's 1. This is all equal to negative 1.28. When you solve for x, you get 0.37. 0.37. So here we're rejecting. We're actually going to reject here. They're going to say reject. They're going to say reject. And hopefully one of the neighbors says, whoa, wait a minute. We've got a problem here. And they say, why? And we say, well, let's go back. We just said 0.32 is a good number. So if we put 0.32 all the way over here, it's still in a different color. It's green because it's good. 0.32. I'm going to erase the word reject. That's equal to 0.37. And we just got a 0.34. So we were in this region. But 0.32 is a good number. Now, what is the probability that we accept this, that it's good? It's this area right here. You draw your line when you reject. You're right here. You're right in here. And if we do the statistics, it's really not that hard now that we've been through it. It's 0.37 minus 0.32 all over the standard error with a 0.32 in it. And we come up with a 2.1. Look in my, I checked the tables, it's 2.144. And that's an area, this area now is 1.6%. So, it's saying I got something good, and I have a 1.6% chance of accepting that something good. Now, the key is here, it has to do with sample size. I tell you, everybody, I mean, when sample size gets big, we can reject any hypothesis test. Be very careful with this. With big sample sizes, now we've got some ideas of our possibilities. Remember we said we have 0.4, 0.32, 0.2. Well, we got a good feel that 0.2 is probably not a possibility because our sample